almost all educated persons in general, and the students of mathematics in particular, are quite acquainted with the number pi. It is the ratio of the circumference of a circle to its diameter. It is an irrational number, which means that it cannot be expressed as the ratio of two whole numbers. Its decimal representation has no end and no repeating pattern. In mathematics, physics, and other physical sciences, pi plays a very important role, and at the same time, we can say that it is the most mysterious constant in the world. This has always been the matter of curiosity and fascination for mathematicians, right from ancient time to the present time. It stands as a symbol of boundless beauty and complexity that a number can embody. Today, I have come with a very important and interesting question. Are decimal digits of pi random? Before discussing this, let us try to understand what randomness means actually. Technically speaking, a random sequence of symbols is a sequence which cannot be recorded by means of an algorithm in a form shorter than the sequence itself. There cannot be any formula or rule to know the next occurrence in a sequence. Now, in this context, I would like to tell you about the magnificent formula of Ramanujan, the great Indian mathematician, for obtaining the value of pi. His formula is 1 by pi is equal to 2 root 2 divided by 9801, summation over n from 0 to infinity 4n factorial into 1103 plus 26,390 n divided by n factorial to the power 4, 396 to the power 4n. The convergence of this formula is extremely fast. For example, if we only use n equal to 0, we obtain the value of pi as pi equal to 3.14159273001. and the error in absolute value is as small as point 0.00000764,235. What a wonderful result. Surprising indeed. This result was sent by Ramanujan to a British mathematician, the then number one pure mathematician of the world, Professor G. H. Hardy, through a private letter written in January 1913. When Hardy saw this result, he was stunned and commented that it was almost impossible for a person to get such a genius mathematical result without any supernatural power. Not only this result, along with it, in fact, Ramanujan sent many other results like this to him, to Professor Hardy. It is interesting to note that computers are being used to find the decimal places of pi using this version of Ramanujan's mysterious formula. Many mathematicians have been succeeded to find the value of pi up to the millions and millions places of decimal. Now the question arises that if there exists a formula for obtaining the value of pi, can one say that the decimal digits of pi are random? In a strict sense, it can't be said that the decimal digits are random. But what our statistical tests for randomness say? Late Professor C.R. Rao, in his book Statistics and Truth, Putting Chance to Work, has mentioned some statistical tests of randomness of these decimal digits. Let us see. It is really very interesting. The first 1000 decimal digits of pi were considered. The observed frequencies of these digits are shown in the table. The expected frequencies, assuming them as random, are also shown. From the table, it can be seen that the digit 0 has appeared 93 times. The digit 1 has appeared 116 times. And so, the last digit 9 has appeared 106 times. Among the first 1000 digits, decimal digits of pi. Now, if we assume that all these digits are random, then we must expect that each of these digits comes 100 times. So the expected frequency for the digit 0 is 100, expected frequency for digit 1 is 100, and so the expected frequency of the last digit 9 is 100. The value of the chi-square statistic for testing the departure of observed frequencies from the expected frequencies is 4.20, which is small for 9 degrees of freedom, indicating close agreement with equal frequencies. The value of chi-square at 9 degrees of freedom and at 5% level of significance is 16.919. This statistical test suggests that the decimal digits of pi are random. To further confirm it, let us consider the frequencies of odd digits in sets of 5 digits out of 1000 digits. Obviously, there would be 200 such sets if we consider the first 1000 decimal digits of pi. The observed frequencies of odd digits are shown in the table. The expected frequencies are calculated using binomial distribution with n equal to 5 and taking p equal to half. That is, assuming that odd and even digits are equally likely to appear. Now in the table it can be seen that in a set of 5 digits, in 7 sets, no odd digit has appeared. In 31 sets, odd digit has appeared only once. And so, in 6 sets, all 5 digits are odd. That is, in the set, there are 5 odd digits. The expected frequencies calculated on the basis of binomial distribution, taking n equal to 5 and p equal to half, are given. The expected frequency for 0 is 6.25, for 1, 31.25, and so the expected frequency for 5 is 6.25. The chi-square for testing agreement with expected values is 4.336, which is small for 5 degrees of freedom. The value of chi-square at 5 degrees of freedom and 5% level of significance is 11.070. This confirms that the decimal digits of pi are random. The sequence of decimal digits of pi seems to have the same property as the sequence of male and female births, or the sequence of red and green balls drawing randomly with replacement from a box containing balls of only 2 colors, red and green. Now, what can we say about the randomness of the decimal digits of pi? We may say that these are the pseudo random numbers, as they satisfy all known statistical tests of randomness. As such, they can be used in all simulation studies to derive valid results which are as good as those obtained by using randomly generated numbers by the lottery method or by computer. Thank you very much. Thank you.